Welcome and thank you for listening to this Paragon Edge audio blog. Advanced function ATM platforms rely heavily on the CNXFS standard to coordinate communication between applications, middleware, and physical devices such as card readers, cash recyclers, PIN pads, and dispensers. XFS is an enabling technology that provides a client-server API for Windows-based ATM applications to work consistently with hardware components and peripherals from different manufacturers. Unfortunately, managing the number of available device options against the supported versions of the XFS standard has become increasingly complex. Today, a typical ATM estate contains a mix of OEM-specific XFS implementations, different firmware and driver versions, and middleware layers that interpret XFS services differently. Over time, this creates what many ATM teams experience as XFS fragmentation. Subtle behavioral differences between devices and services that technically follow the same standard, but behave differently under real operating conditions. The challenge is that XFS fragmentation rarely produces immediate or obvious failures. Instead, it introduces edge case behavior that only emerges when specific combinations of services, timing conditions, firmware versions, or OS updates interact. These failures are particularly dangerous because they often pass standard lab validation processes and early testing phases, only appearing later during pilots or in live production environments. The following real-world failure modes illustrate how XFS fragmentation can impact ATM reliability and why modern ATM testing strategies must account for these hidden interoperability risks. These are the types of failures that escape ATM test labs, only to surface and cause problems at the worst possible time. Example 1. OS patch exposes XFS service timing issues. After a routine OS security patch, intermittent failures may begin to appear during card insert, PIN entry, or transaction initialization, even though no application changes were made. This often occurs because OS updates can subtly alter thread scheduling or system timing. As a result, XFS services may respond slightly faster or slower than before. When application logic assumes deterministic service timing, these small timing shifts can trigger unexpected behavior. The operational impact can include sporadic card capture events or transaction cancellations. Because the failures are intermittent, they are often dismissed as environmental issues or labeled as non-reproducible. In many cases, successful pilot testing can mask these risks until a broader rollout exposes the problem at scale. Virtual ATM helps address this challenge by enabling repeatable timing and stress scenarios. This makes it possible to expose race conditions and timing-related issues that physical lab environments often fail to surface. Example 2. Peripheral firmware update breaks unrelated services. A firmware update to one peripheral, such as a recycler or card reader, can lead to unexpected failures in transaction flows that appear completely unrelated to the updated device. This typically happens because vendor-specific XFS extensions may change subtly during firmware updates. At the same time, downstream services may rely on undocumented behaviors that are not formally specified. Since integration testing often focuses only on the device being updated, these indirect dependencies can easily go unnoticed. The operational impact can be significant. Features unrelated to the update may start failing in production, leaving teams struggling to identify the root cause. Troubleshooting can become slow and inconclusive, often forcing organizations to pause or roll back rollouts late in the deployment cycle. Virtual ATM helps mitigate this risk by supporting service-level isolation testing. This allows teams to validate how a change in a single XFS service can affect the broader transaction workflow before the update reaches production. Example 3. Mixed OEM estate produces inconsistent error handling. In environments with multiple OEMs, the same physical error, such as a note jam or shutter obstruction, can produce different XFS error codes depending on the device manufacturer. This occurs because OEMs may interpret XFS specifications differently. As a result, application logic may handle some error variants correctly while failing to recognize others. Testing environments often assume consistent error behavior across hardware, which can mask these discrepancies until systems are deployed in the field. The operational impact includes inconsistent customer messaging and unpredictable ATM behavior. Some machines may recover gracefully from the error, while others may go out of service. Across regions or clusters of different OEM hardware, the issue may appear as seemingly random behavior. Virtual ATM helps address this by allowing teams to model OEM-specific XFS responses and validate that application behavior remains consistent across the entire ATM fleet. Example 4. UAT passes, pilot fails due to real-world XFS diversity. In some cases, user acceptance testing, UAT, completes successfully, but pilot deployments begin to fail once exposed to real production traffic and configuration diversity. This often happens because UAT environments simplify or idealize the XFS stack. In production, however, additional services, extensions, and configuration variations are introduced. Interactions between these services, especially at scale, may never have been exercised during testing. The operational impact can include late-stage rollbacks, feature disablement, and reduced confidence in testing results. Operations and InfoSec teams may also increase scrutiny, slowing deployment cycles and adding pressure to remediation efforts. Virtual AM helps reduce this gap by enabling teams to test against production-like XFS service matrices earlier in the development and validation process, aligning UAT outcomes more closely with pilot stage reality. Example 5. Recycler accepts cash deposit workflow fails mid-transaction. A cash recycler may successfully accept notes during a deposit, but the transaction fails when the application later requests escrow confirmation or recycling status. This typically occurs because the recycler's XFS service may use a newer event model, while the application or middleware expects a legacy event sequence. In some cases, lab testing may also have used a different firmware version or XFS service implementation than the one deployed in production. The operational impact is highly visible to customers. A failure occurring after cash insertion can result in delayed funds, reversals, or manual reconciliation processes. These issues are also notoriously difficult to reproduce outside of real field conditions. Virtual ATM helps by simulating multiple recycler XFS behaviors and event sequences, enabling teams to identify these incompatibilities before deployment. Modern ATM estates combine multiple hardware vendors, device firmware versions, middleware layers, and OS builds. Even when each component individually complies with the XFS specification, subtle behavioral differences can emerge when those components interact in real transaction workflows. Because these issues often depend on timing, sequencing, or service-level interactions, they are notoriously difficult to reproduce using traditional ATM lab environments. Physical test labs typically represent only a small subset of the possible XFS combinations present across a production ATM fleet. This is where Paragon's virtual ATM platform plays a critical role. Virtual ATM provides a virtualized environment that simulates ATM devices and XFS services, enabling teams to test how applications behave across a wide range of device responses, timing conditions, and service interactions, without relying on physical ATM hardware. By allowing teams to model different XFS behaviors, device implementations, and workflow scenarios, Virtual ATM helps organizations identify interoperability issues earlier in the development cycle, validate application behavior across diverse ATM device environments, reproduce edge case service interactions that physical labs rarely expose, and increase confidence that tested workflows will behave consistently in production. As ATM ecosystems continue to grow more complex, testing must evolve from validating individual transactions to validating the behavior of entire XFS service environments. With virtual ATM, ATM teams can move closer to that goal, detecting the hidden effects of XFS fragmentation before they become visible to customers. Thank you for listening today.